Here's your review on cubes and cube roots. So what is a perfect cube? A perfect cube is a number that you get when you take a whole number and raise it to the third power. So you take that number, such as 3, and you multiply it by itself, and then you multiply it by itself again. In this case, it is 27. 3 to the third power is 27. A perfect cube represents the volume of this cube if the side lengths are whole numbers, because in a cube, all the side lengths would be the same. So in this example, if the side length of the cube was 5, 5 for the width, 5 for the height, and 5 for the depth, you would do 5 times 5 times 5, which could also be written 5 to the third power, and you would get 125. 125 would then be the volume of this cube, and that is the perfect cube. So to find the cube of a number, all we have to do is multiply the number by itself, and then do it another time. Multiply it by itself again. So for example, if you wanted to find the cube of 8, you would do 8 times 8 times 8, and when you do that, you get 512. If you wanted the cube of 11, you would do 11 times 11 times 11, and you would get 1,331. Okay, as a last example, if you wanted the cube of the number 14, you would do 14 times 14 times 14. And your answer there is 2,744. So then what is the cube root? Well, the cube root, we use this little symbol here. Looks like a check mark. And there's a little 3 up here to show we want the cube root and not the square root. If we want the cube root of a number like 343, what that means is that the volume of your cube is 343, and I want to know the side lengths. I want to know what this side is, and that side, and that side. So your cube root is just equal to the side length of the cube. So the big question is, how do we find the cube root of that perfect cube? If you're given a number, for example, such as 64, and you're asked to find the cube root of that number, how do you find it? It seems like it could be a little confusing, but there are actually 2 ways to get this. The first way would be to use a calculator. And when you use that calculator, basically what you're doing is guess and test. You're going to estimate what you think the number is going to be, and you're going to multiply it by itself and then by itself again to see if you get to 64. The second way would be to use prime factorization, which may in some cases be a little bit quicker. When we're looking for the cube root, you want to remember that you're looking for a number times the same number and times itself again. So you're going to do your prime factorization for your number, such as 64. So I'll start with 64. And using either method for prime factorization will work. If you don't remember those methods, you should go back and watch the prime factorization video that was available to you. So here we have the prime factorization for 64. And what I'm trying to do is split this prime factorization into 3 equal groups. So I notice that I have 6 2's here, and that would be 3 groups of 2 2's. So I have my 2 times 2, my 2 times 2, and my 2 times 2. And then each of those would go into up here, okay? And then to make it easier for myself, I would multiply those out. 2 times 2 is 4, another 2 times 2 is 4, and then of course the last one is also 4. You're looking for all 3 of those numbers to be the same number, and then that number is your cube root. So we would say here that the cube root of 64 equals 4. And just to give you a second example here, if we started with 3,375 and we start to factor that, we would have 25 times 135, and I know that neither one of those is prime, so I'm going to keep factoring it. And then I get this string of factors that I have down here at the bottom. When I'm done, I have 5 times 5 times 5 times 3 times 3 times 3. And with the commutative property, I know that I can switch those numbers around and do them in any order that I want. So just to make it easier to look at, I'm going to make this 5 times 3 times 5 times 3 times 5 times 3. I still have the same number of 5s and the same number of 3s in my string. So we can see that I have 3 groups of 5 times 3, which tells me this is indeed a perfect cube. And each of those is equal to 15. So my cube root here of 3,375 equals 15. So what happens if you are asked to find the cube root of a number and you get like really stuck? You're not sure what to do. So if we have, for example, the question, the cube root of 2,197, and you just can't remember what to do. So your strategy here should be to guess and test to see what you can find. You know that it's going to be the same number times itself times itself. So here you might want to start with 10. You know that 10 times 10 times 10 is 1,000. Okay, and you know your number has to be bigger than 10 then, because your cube is bigger than 1,000. So maybe then you go into your calculator and you try out 12 times 12 times 12. And you find that you get 1,728. You might then choose to go up to the next number or to skip around, but you are certainly getting closer. So you might go and find that 13 times 13 times 13 is 2,197. So you can always use that testing method to find the cube root if you're not comfortable using the prime factorization. So your answer here would be 13, and you use that with that guess and test method, and that's perfectly okay to use.